So learning target 5.4, we're going to derive and use the law of sines today to help find missing sides of triangles. If I told you right now in this picture, okay, to solve for side C, and I'll even give you a value here, let's say it was 10, whatever, okay, why would you not be able to do this? Or maybe some of you think that you would, but why would you not?
No, the 90.
It's not a right triangle. You can't use SOHCAHTOA if it's not a right triangle. Okay? Sine of some angle equals opposite over hypotenuse if you have a right triangle. If you don't have a right triangle, you don't have a hypotenuse. Okay? So you would not be able to solve this problem right here using what you know already, SOHCAHTOA stuff. You couldn't say the sine of 31 equals 10 over C. That doesn't work. Okay, C's not your hypotenuse. There is no right angle here. So we got to have other ways because not every triangle in the world, unfortunately, is a right triangle. Okay, so we got to have other ways to figure out missing sides of triangles to find the different lengths. All right, so we're going to use what's called the law of sines, okay? And I'll show you how we can figure out the law of sines from things that you already know, all right? So I'm going to change this picture here. I'm just going to put a bunch of variables in, okay? And I will go ahead and tell you this. The next time you take the test on Learning Target 5.1, you'll be asked to derive the law of sines. And I'm right now going to derive the law of sines.
Why is it retaking 5.1? Why is that on 5.1?
Because 5.1 is more of a vocabulary slash writing slash why trigonometry. It's all about the more on the why instead of the process necessarily, okay? So deriving law of sines, all right? We'll probably give you a picture like this, but then we'll say go. Derive the law of sines. Okay? So, here's what we're going to have to do. First of all, notice I have side A, it's across from angle A, side C is across from side, or angle C, and so on. Okay? I'm going to drop a perpendicular down from the top up here. Okay? So drop a perpendicular down to the base, making a right angle. And also what I did then was I made two right triangles now, right? Okay. Any idea what variable I'm probably going to give that? Probably not A, since there's an A there.
H.
How about H? Why?
Height.
Height. Okay, that seems logical, right? Okay. It wouldn't have mattered, but I think H for height makes pretty good sense. Okay. Now I have some right triangles. Now can I set up some trig ratios? Now can I use SOHCAHTOA on the right triangles? Sure. What would the sine of angle A equal? H over C? Okay. How about I do the sine of angle C? H over A. Okay. I'm going to get these two put together somehow. All right, I'm going to get these two equations put together. I'm going to solve them both for H and then set them equal to each other. Okay. So I'm going to solve for H. How do I get H by itself? Multiply by C. So what do I have now? C times the sine of A equals H. And over here,
You would have the
which would be what?
A times
C.
A times the sine of C
Oh, yeah, yes.
would equal H, right? I multiplied both sides by A. Now what do you think I'm going to do?
Substitute.
Why can I set them equal to each other? H equals this and H equals this. Well, if H is equal to this and H is equal to this, those two thises have to be equal, right? For lack of better terms there. Okay, very mathematical, I know. Make a good video, lots of hits on YouTube. It's baby. Okay? So C times the sine of A has to equal A times the sine of C because they were both equal to H.
Got that right.
And now what I'm going to do to kind of finish this, I mean this is fairly simple here, but to finish it, make it look a little bit better, I'm going to get all my A's, if you will, onto one side, and all my C's onto the other. Okay?
I have to go to a course lesson. I didn't realize I did, so just got a text. So just something else with it.
Let's stick around for,
I can stick around for like 5 more minutes.
yeah, it won't take that long. Okay,
You wanna do it?
listen. We're going to get C's on one side, A's on the other. Okay? So I'm going to divide by C, divide by C. So now I have the sine of A is equal to A times the sine of C over C. Divide by A, just for making it easier to look at, I'm going to put times 1 over A on both sides. Because that's the same thing as dividing by A, right?
Yeah.
Dividing by a number is the same thing as multiplying by that number's reciprocal. So I'm going to multiply both sides by 1 over A. What happens to the A's then on this side? They're gone. So now I have the sine of C over C equals the sine of A over the A. Okay?
What does that do then?
And this, okay, this right here, which there's going to be one more thing, but this is your law of sines. Okay? This is your law of sines. I'll show you how it works in a second, but I'm showing you how we derived it first.
So that's what we
Okay.
did to derive.
Your deriving will be exactly what I have written here. Yes.
You memorize that.
Yes.
Alright.
It's not really memorizing. All you got to do is drop a perpendicular and then use SOHCAHTOA. Okay? Now, also, real quick before I pause this, and we'll move on to some examples, okay? We could have done this differently and dropped a different perpendicular. Made different right triangles. Would you guys all agree? We could have done it so that we actually involved the B and the B, right? Okay? Well, we'd end up getting the exact same thing. You would see how that equals B over the sine of B. Okay? So that is your law of sines. Okay? It is basically saying that if you take the sine of angle A over the side A, whatever ratio that is, that ratio will be the same ratio as sine C over C, as sine B over B. All of those ratios will be identical. And you'll be able to use that to help you find some missing sides. And I'll show you again with an example in a second. So that's your law of sines. Go ahead and pause it.